Hello, everybody. Welcome. This is the info session for the Data to Discovery Data Visualization Summer Internship Program for 2021. In the next hour, we'll be talking about who we are, the organizers. Then we'll tell you a little about the structure of our program. Then we'll tell you who are the interns that are most successful in our program and who would like to see apply. And then we'll tell you how to apply. We'll follow with a session for questions and answers. And then we'll just wrap up with what you should be doing next to apply and get involved in our program. So a little bit of ourselves. My name is Santiago Lombeira. I'm a senior research scientist at Caltech as part of the Center for Data-Driven Discovery, as well as faculty in interaction design at the ArtCenter College of Design. With me are my three co-organizers, Scott Davidoff. He's the Senior Manager for Human-Centered Design in Mission Operations at NASA's Jet Propulsion Laboratory, JPL, as well as Maggie Hendry. She's the Professor and Chair of the Graduate and Media Design Practices Program, as well as the Undergraduate Interaction Design Program at ArtCenter College of Design. And finally, who we hear from next is Hilary Mushkin. She's a research professor of art and design in engineering and applied sciences, as well as the humanities program at Caltech.
So I'm going to tell you a little bit about the structure of our program. Next. So just to, first off, a little bit of house cleaning, I guess, here. Because this is a NASA JPL project, we have certain requirements that we need to follow when we hire interns. Those are, the students that we hire have to be continuing past the summer. So they have to be graduating later, meaning that if you're graduating before the fall of 2021, you are not eligible for the program. They need to have a GPA of 3.0 or higher, and they need to be US citizens or permanent residents. This is the other additional thing that now, because we're doing things in the virtual world, is that they need to be in a US location for the summer period. In pre-pandemic times, that wasn't a discussion point because we would all be together in person. But now this is something that we need to state. So those are just some prerequisites for applying. Okay, next. Our program has been running for 8 years. We're heading into our 9th year. Next. And it's a very interdisciplinary program, as you may have gathered from hearing who the 4 of us are that co-organize this program. We bring a diverse range of backgrounds to the program. Art, design, human-centered design, human-computer interaction, visualization, all of these are skills that we bring to the program and interests that we bring to the program. When we collaborate with science and engineering partners, we ask a very sort of broad question, which is how do we actually get to discover things in science? And that how is part of what we engage with over the summer. And the way that we get to answer that question is through a process that involves design, it involves science, it involves art, and it involves computing. So when we structure a team, it includes an interdisciplinary group of mentors. And then it also includes, you can go to the next slide, science partners. So here we look for very specific kinds of visualization questions in science that we know we can contribute to based on our skills. Those are hard problems because we have a whole summer to work on them. They are interdisciplinary, they're user-centered, and they can, and we take an iterative approach. They're also visual in some way. We hire 5 interns in the summertime, 3 computer science students and 2 design students. The way that the program, you can go to the next slide, please. The way the program is structured is that each of the computer science students is dedicated to the code for one of the 3 projects, and the design students work on all 3 projects. And then we mentor the entire group. We meet with the students weekly, and we'll talk a little bit more about the process in a little while. But despite the fact that we ask the computer science students to be dedicated to the code for each of the projects, we do have a highly collaborative environment, and we look for students who want to help each other on different aspects of their projects when they can. Next. So the program, I'm just going to give you a little sense of the timeline that we work with, so that when you are thinking, if you're thinking about applying, you can kind of understand what to expect. So we're in the process right now of soliciting proposals from researchers at Caltech and JPL, and we will be reviewing proposals in the coming weeks. In January, we start actually talking to potential collaborators to learn a little bit more about their projects and whether or not we think that they're a good fit for our program. That's the same time that we start interviewing students. And what we're looking for is really a match between the kinds of skills that we can provide as a team and the kinds of problems that the research projects actually propose to us. So while we're sort of doing that interviewing in parallel, we will be, as I said, we'll be interviewing students starting in towards the end of January, and we'll be finalizing teams by the end of March. However, as soon as we know we have a match between our team and the research groups, we will make an offer. Okay, next. So this is a 10-week summer program. We start in the middle of June and we end in the middle of August. The precise dates are on our website. Actually we start on June 14th specifically and end on August 20th. There may be some wiggle room in there. Things might change a little bit, but that's the proposed timeframe right now. The first couple weeks, we do a deep dive as a whole team into all 3 of the projects that we're working on. So everybody gets to learn about the science and the data from all the 3 projects, even if you're a computer science student that's not necessarily going to be working heavily on one of those 3 data sets, or 2 of those 3, you're only going to be working on one of those data sets really heavily. But we all together work as a team at the beginning so that we can help each other throughout the summer. And that's really fun because we get to learn about science in a way that you really wouldn't otherwise, because you become a collaborator with the research team during the summer. So for example, last summer we did a project with a research group at Caltech that is studying relationships between the biology and the geochemistry in the deep sea. And so we got to learn a lot about that in the first 2 weeks, and then the team members that were working really specifically on that project continued on that project throughout the summer. Another example is that we worked on a project with a group that is modeling clouds in the globally to understand how they affect climate change. And that was something that we got to delve deeply into in the first 2 weeks. Then starting in towards the beginning of July is when the students get to the business of designing with exploration and prototyping and data digestion. Towards the middle of the summer, this is an iterative process that happens over and over and over again, and it involves user-centered research, which Maggie is going to talk about in a minute. Towards the middle of the summer, we start to kind of nail down a particular idea for what is going to be developed. Specifically, the development happens starting thereafter, refining and testing until we do delivery of a prototype that is actually working and that our research teams can use and do use thereafter. So I'm going to pass it off to Maggie now to tell you a little bit more about the design process.
Hi, I wanted to talk a little bit about some of the skills and approaches we take that are based on methodology that I think many of you in the design world are very familiar with. It is human-centered design, contextual inquiry, and integrating with a kind of agile-based development approach. That really means that we're spending the first few weeks of the program really trying to understand the scientific hypothesis, the challenges, the opportunities, and we're doing that kind of in tandem with understanding where the data came from and how it works. So really we're going through that cycle of planning research, creating prompts, prototypes, participatory design sketches, actually designing the session with the scientists and the other end users. We're working through high-level analysis and then ideation, creating more prototypes. And as you see, this takes place on a lot of whiteboarding, post-itting, or in today's world, we're on Miro a great deal. Developing that from models to kind of explain, have we understood you? Is this what this means? This example is actually from genetics and 3D DNA. And you see how the students and participants actually started to create things that were in pipe cleaners, but also sketches. So playing with those sketches, having people respond to them, ideate on them, add to them, as well as starting to build in UI components for workflow. You see here in the bottom left-hand corner, we actually have a mixed fidelity prototyping. So we're also doing a lot of thinking and work on how do you design participatory research in this field. And here we see that we need a certain level of fidelity in the data. So it is actually computationally integrated into an interface, but we're still playing with interface components, right? So that type of design development, as well as the ability to facilitate, are really important in the design team. And that includes team members who are also able to do the information design, the sketching, and also some of the programmatic animations. So overall, in the design leads, there are opportunities to practice and learn from graphic and information design, experience design, graphical user interface. We're looking for participants who have experience with foundational prototyping tools, as well as an understanding or at least some exposure to HTML and JavaScript. So with that, actually, I'm going to turn it over to Scott, who can talk about why this kind of practice matters and what some of the outcomes of our previous projects have been.
Thank you very much, Maggie. So I think one of the things that's so exciting about the work that we take on in this program for me is that we really try to answer questions that advance basic research across a very wide array of different science problems. And so kind of included this, one of my favorite papers here from Lewin here, and it kind of talks about some of the actual impact of doing, of designing these interactive visual analytic systems. And of course, in this particular experiment, they designed a controlled study where they injected latency into the compute time. And they found that not only does more latency slow down the space of analysis, but it actually affects the questions that the science team is able to access. So I find that a really great example of the consequence of being able to do the design of these visual analytic systems in the physical sciences and why they have such important consequences. I think another example of what makes this an interesting and hard domain, I think you can see on the next slide. This is an abstraction, hopefully many folks will be familiar with it, but from Jacques McKinley's thesis, where he's basically tried to create this ordering of the human cognitive system. In other words, how well can the perception determine meaningful differences when visual encoding is mapped onto all of these different different visual encoding types between the length or the angle or the slope. It turns out that people can actually differently perceive differences. And of course, this maps heavily onto the effectiveness of different data visualization systems. And of course, this particular view is a higher level abstraction that he built on top of many, many years of experiments from some folks like Cleveland and McGill to try to come up with a kind of guidance system for people designing visual analytic systems. And of course, what's very hard and very complicated about this is that even if you could memorize it in one of the dimensions, it actually varies across the different data types. Anyway, this is one of the things that makes problem solving so difficult in being able to build visual analytic systems. So how do we use these kinds of things going forward? So this slide of many colors here is, I think, a screenshot from each of the different 25 application areas that we've built as part of this program, and that we kind of showed to give people an insight into the range of disciplines that we've really touched on. And you can see just how many different types of systems we've come up with. And in this slightly less overwhelming, but still probably overwhelming example, you see examples in the top left. This is a system where we built that is actually going to be put in use for the Mars rover drivers in this upcoming mission, Mars 2020, or maybe folks have seen it as the Perseverance rover. And it's a tool that allowed us to compare and evaluate the risks associated with different possible rover paths. And below it is, for example, a control device that we used for the LIGO experiment, which some folks might know in their discovery of the gravitational waves was given the project that was given the Nobel Prize in physics just a few years ago. And this is a system that uses a resonant laser interferometer that is so sensitive that it can determine perturbations below the width of, I think it's a neutron. I mean, it's such an incredibly small size. And so the particular tool that we built here helps the operators to disambiguate false positive readings. Just reading across the bottom, you've got the physics of granular solids, you have forests of genetic trees, and the design and evaluation of trajectories for different spacecraft analyses. And just looking at this, I think about, boy, we've touched a lot of different problems in this particular program. And I realize one of the questions folks might have is, well, what are we going to do this summer? And we're not sure exactly yet. But I think if you can look at any of these, at this forest that we've put in front of you and see anything, it's that there's a wealth of exciting problems that folks at JPL and Caltech really get to work on, and that they bring to us as part of the program. And they say, we're not sure where we can go. And in almost every time we've come up with really interesting new ways for them to conduct analysis. Maybe that makes a good transition to the next slide, because I think one of the things we want to share is how has this worked across the different projects. So this is a list of some of the highlights of the outcomes for some of these different partnerships. You can see that they have included deliveries of research. So to the APS is the American Physics Society. So we had a video that we're able to share at their Gallery of Fluid Motion. We've been able to get funds invested to allow us to continue to work with that student who did the project, as well as some of the stakeholders here in the visualization program, and to continue that work. And we've shown some examples of how we've done this on the cell lineage, as well as the 3D DNA. We've actually put together proposals where we've gotten, about $500,000 from NASA to be able to continue to create a full product and deliver it to all the space missions that are going to be used. And we've, of course, for those who are interested in research careers, we've actually had a student go on to get a NASA fellowship that sponsored their PhD. And we've had papers at the top Viz and HCI conferences. And we're happy to continue the work in whatever ways are exciting with the students that we partner with. And we're happy to find ways to allow them to stay involved if that's something that they're interested in, and it's something that their advisors and universities can allow. And so we've been able to continue partnerships for certainly a year, often many years, and they've been exciting partnerships all throughout. So I think, I'm going to hand it over to Santiago at this point to talk about how we get involved.
So as you can see, so many of the projects that we work on are just amazing stuff. And all the work that we showed was 100% done by the students. So it takes a very special student to accomplish the work that we're showing. And the coolest part about it is that we really live in this intersection between science, art, and design, and visual communication. Next, you already heard from Maggie how the different requirements that we ask for design students, but overall we love the idea of transdisciplinary students, people who can span the whole range of things you can do on. Next, so particularly for the CS, and for those of you who have perused the application already, we don't expect you to know all these things, but some of these are some things I've actually used in the past. There's been a lot of JavaScript and React recently. Knowing processing or open frameworks or Cinder are really good things to have. Having some understanding of data visualization using either D3 or ParaView are also big pluses. So none of this is required, but and not only that, but it's very much about being flexible and being able to understand the things as they come along. So when we start our projects, we do not have a particular programming language or environment we're going to develop in, even if the researchers have one that they're particularly attached to. We just leave it open, and we start from a very organic place to say, okay, let's do prototypes, let's do tests, what software's out there that will help us, what language will help us accomplish our goals. And as it goes along, it kind of narrows down. We have things done in Open Inventor and C++ in years past. We had things in open frameworks. And like I said, recently, there's been a lot of JavaScript and React. Next. So as you'll see with the form, you can fill out for the CS leads what the things that we hope that you know, and you can say levels, and same thing with the design leads. But like I said before, our students tend to kind of cross boundaries. Our CS leads, we have some amazing illustrators and filmmakers and game designers among the people that we've hired. And the opposite is true as well. The design leads, lots of them have been science buff and really strong coders. Even though there is 3 CS leads and 2 design leads, there's been, and we choose each of the CS leads to spearhead each of the projects, just so we can have somebody responsible at the end of the summer. Some of the projects have actually been coded, 50% between 2 of the CS leads. There's been a couple of projects where actually the design leads have actually taken over and done like 70 to 80% of the coding. Actually, just this last year, there was almost a flip of roles where the CS lead did a lot of the design, and the design lead actually did a lot of the coding. And it's just because we expect people with that much nimbleness and depth as they apply. So you don't have to know everything; you just have to be willing to learn as well. Next. So this is what the composition of the teams look like. This is just 4 sample years. The 3 on the left, obviously, we were able actually to come to Pasadena and go to the Mars yard and actually look at the rover, where they actually get to test the different ground and how it handles the rocks and the tires and everything. And on the right, you can see that we actually had to go online last year. Next. So this was the first year to go online, and we really expected it to be difficult. So our expectations were lowered, and it turned out to be one of the best years ever. Yes, there was a bit of some fatigue, but I think we were able to handle it fairly well. We have stand-up meetings every morning with these 6 bright, shiny faces. And after that, we have plenty of time to actually work on your own. And then at some point, you have meeting either with the stakeholders or with the mentors, which you can see here. One of our sessions, we're using Jamboard or Miro or Explain Everything to actually share these science sketches. And then we get also to bring in some of our past alum to actually come and actually kind of create a much larger community, and you get to really hear from people who've done this work before, who are there already, they're doing their PhDs or they're faculty somewhere else, or they're doing, or they're actually working at NASA as well. So how do you apply? So hopefully all of you guys by now have gotten here because you saw a flyer or a poster. Next. So in both of those, you should see both the link to our website, dataviz.caltech.edu, as well as a quick bit.ly link to an application form. This is an application form just internal to our program. And in it, you will see all sorts of questions about your background, about your skills. Next. And it is a Google form, and it is an application from which we'll start figuring out who best fits our program. Like we said before, you have to be a continuous student. You have to have a GPA of greater or equal to 3.0. And you do have to be a U.S. citizen or permanent resident. And even if you are, you have to be in the U.S. when you start the residence, the internship. Because we're going to mail you, badges and equipment. So you have to be in the US, so we'll know. The salary for the whole 10 weeks is $7,300 for undergrads and $9,000 for grad students. And that's just the standard salary across Caltech and JPL. And the location will be online, just like last year. We're not planning on going in person at this point. I think we're just going to stick with online because it seemed to work really well and just makes it easier for us to plan ahead. Next. So as far as timeline, so the application form is open already. So please fill it up. We're going to start reviewing the applications from students fairly soon, and as they come by, we're going to start try to make some time to start interviewing people. So we usually try to get to applications within 2 weeks of us receiving it, but we really actually keeping our admissions open all the way until the big deadline, which is in February for February 9th for CS leads and March 9th for design leads. And yes, right now we do not know what projects we are choosing. We are going over the proposals, and so we should be getting a lot closer to the decisions towards the end of December, and we need to make a decision by the end of January. So because we are working with collaborators, and even though you're part of the Data to Discovery program, you actually will get hired as a NASA summer internship program through the project that you're working on, which means that after we figure out who we want to work and we pair people with the projects that we choose, then that's the internal acceptance. And at that point, people who get accepted will be asked to actually submit an official application to NASA. And that only takes like a week or so to clear, and then you will be formally accepted into the system. So there's a little bureaucracy towards the end, but at the beginning, it's just pretty straightforward. You fill out the form, and hopefully you hear from us fairly soon. And hopefully you've noticed that we do try to keep a diverse team. We do try to be fair about everything, and I think that shows from our past years. But we're committed to that. And at this point, I think we'll open it to questions. And there seem to be some on the chat, right?
Yes, I'm going to stop sharing my screen so that everyone can see one another who's involved in the conversation. Yeah, and I wanted to pick up a couple of questions that are already here. I think one is, can you apply simultaneous to both design and computing science? Yes, you can. Obviously, we're a small group of people. As a group of 4 mentors and program directors, we review and we actually have a conversation with you about what is the right fit for both your skill set, but also your goals. What is you want to learn in this team? So yeah, we can consider you for either role depending on that fits.
Maybe I could respond to, it looks like there's a couple questions, one about multimodal interfaces and the second about XR. So there are actually research areas that are very interesting, I think, to all of us. And I know Santiago and I, for example, do a lot of work, and Maggie was just in the process of creating an entire VR lab over at ArtCenter. So, right, this is an area that we're actually really interested in. And it's something that we've thought about trying to include, but we have not, we've decided to avoid including it largely because of the 10-week constraint on the program length. The main idea here is that the projects have to learn, let's just pick any one random example. You have to learn about the 3D structure of DNA and how scientists understand, analyze, model, and encode all of those things. So that deep dive tends to be a really big one, especially for the students, you know, on that project. And so that tends to take such a large amount of time. And because we also want to deliver a prototype that doesn't just do a kind of small amount of things, but actually makes a kind of functional quantum of progress towards solving a very hard problem. So one of the things that we've, in our own personal work, have seen when we're working in multimodal or in XR, that doing even basic things in these different disciplines can be very difficult without strong design patterns. And so because it's added such an additional level of complexity on top of what's already a very large bite of technology to take on, we have tended to avoid doing so. Yep. That said, I think if we had an idea in one particular year, it might be something that we could think about. And in fact, we have thought about it in the at other times, dedicating an entire year where all the projects were on XR or something like that, so that we could all benefit from the kind of baseline work. And we could only work on, for example, one project instead of 3, so that we kind of get a force multiplier. So anyway, yeah, I was just going to say, why don't everybody else share too here?
So I would add to that, like we said at the beginning, it is very much about a creative process. So while in parallel, you are trying to learn the basic science that goes behind all the stuff that we're doing. Again, nobody's required to get a PhD in whatever, in ocean science or spacecraft trajectories. Is really just understanding the basic things that are required to build the understanding. And we do have the data from day one, which is also very, very important to us. At that point, we really ask people to be free. We really love when people bring out the pipe cleaners and the styrofoam bowls and figure out a way to actually construct 3D models. We love that. And we encourage it. So there's nothing at the beginning, like Scott was saying, that really stops us from doing a VR, AR, XR, multimodal interfaces. But as we test this through prototypes and through the user, then usually we realize, yes, it's nice to see the DNA in 3D, but what is really that you're trying to do is like, we're trying to pick out this chain. Well, how do you pick out that chain? And then what do you want to see from it? It usually tends out to flatten out. I know we did a project with sending communications from Mars to back to Earth, so we had to look at satellites. So they actually used the HoloLens for a couple of designs, and they did a little really fun little AR experiment. And as an experiment, it was great. We learned lots of really cool things from it. But the ultimate design was, again, a flat screen. So there's no requirement, and we encourage people to try things. Unfortunately, because this will be online, we can't have the labs available to you guys to play with all the fun toys. Anyway, that's all I wanted to add. Do you have any more questions?
Yeah, I have a question. Have you guys had students in the past that I guess take on a design role in the program that have like a primarily fine art or studio art background? Because because I'm like sort of my field is like contemporary art that crosses over into technology.
Mhm.
Have you had people, is it always like really sort of like user interface, like design based
No.
stuff, or is it art as well?
Yep. I can speak a little bit to that. One of the programs, the Media Design Practices program here at ArtCenter, is an MFA program, and we've had several very successful students from that program participate, as well as other colleges and schools, so don't be put off. But what we're really looking for is the team dynamic, right? So you're not a designer on your own. So you may find that one member of the design team has a very strong background in HCI and facilitation, and another member has a strong impetus towards, creative prototyping, visual languages, exploratory and experimental modeling, and that together that's a great team, right? So that's why the team structure and finding the right projects and the right dynamic matter more to us based on your portfolio and your interests than the type of program you come from. By definition, we're looking for unusual people, right? Or people who haven't necessarily taken the most straightforward path.
I will add one other thing to that, which is that one of the things that is sort of hard for us to list in a form when we're talking about the kinds of things that we want students to have when they apply, or that we think serves students well when they're in the program, is a certain kind of flexibility. And so that's something that I think we're sort of trained to do as artists, but not necessarily trained to do as computer scientists, for example. But it is something that, and when I say flexibility, I guess I could be a little bit more specific, which is that our program gives the students quite a lot of independent responsibility. We do, we do select the projects and the research groups that we're going to collaborate with. We don't meet weekly with the students and the researchers. The students meet with the researchers and they show the researchers their work weekly, and the students show us what they've been doing weekly and tell us what the feedback is that they've received from the researchers. But the development of the project conceptually is something that the students have a lot of responsibility for. And that's something that takes a certain kind of intellectual maturity, which I think is not domain or sort of field specific, but is really specific to any individual. And it also means that the interns that I think work best with us are students that are comfortable with navigating ambiguous situations, because we don't necessarily give all of the sort of, next do this, next do that. We're not kind of managing students in that way. That's one of the things that, we have many former interns who've told us that this internship is the most formative thing that they've ever done. And it is because we do actually give them a lot of leeway to, we're not just saying, see you later. We do give them a lot of support, but we also give them a lot of opportunities to develop something which they need to navigate.
So I would say, add to that, yes, this is very much a professional internship. When you come here, you do end up working quite a bit. And you're not completely on your own. We are there, online. We meet with me daily in the mornings for the stand-up meetings, and then we have meetings with Scott, with Hillary, and with Maggie, and then we have the meetings with the stakeholders. But to go back to your original question, do we look for artists? I think that's where your portfolio becomes really strong. It's about if you have pieces in your portfolio where you do incorporate data, and the display of data is not just, you use the CO2 level to just draw, a fuzzy cloud, and that's the end of it. But, did you really use the data to say something meaningful, to translate that data and locations and levels of something? And there's really depth in the portfolio piece that you show. And that's true both for the CS and the designs as well. the other way, the designer and the CS leads. You know, if you have a GitHub and we show, wow, you did work on this project, and it wasn't just superficial tackling of the data, but there was really in-depth analysis of the data through the tool. That's the things that we love, regardless of your education.
I'm going to build on Santiago's comments in response to Pamela's question about what are we looking for in a design portfolio. Again, depending on the designer's background, really looking for process. How has a designer moved from an insight through ideation into multiple fidelities of solution design or solution development in partnership with end users, right? So contextual inquiry examples, low to high fidelity prototyping examples, clearly distinguished decision points, either pivots, insights, failures. I love, love, love to see things like great ideas that turned out not to be and what was learned along the way. From a user interface perspective, particularly interested in people who have done workflow, more in the line of productivity interfaces, not just interfaces around small app solutions, people who enjoy complex data and how the complex data creates new scenarios and new functionality for the system behavior, but also for the end user. And frankly, there's also people who are looking for designers who love, love, love the visual qualities of information design, right? And that's our classic skill sets, right? People who love type, animation, transitions, layouts, communication design. So that's a broad spectrum. I don't expect any one individual, or we don't expect any one individual to have nailed every one of those components, but a coherent selection of those types of skills and projects that articulate that are really welcome.
Adam Costilla, I think you had a question. You raised your hand.
Or Adam.
Yeah, can you guys hear me?
Yeah.
Yes.
Awesome, yeah. Thank you for putting this on. This is really great. As I'm starting to know your names and see these faces, I'm wondering how much we're going to be working with you guys specifically versus, like you said, the projects that you get are from people that are requesting. So like, do we go off and work with other people and then it's like you guys are just the program managers, or do we still get to interface with you guys? Or
yes, Santiago, do you want to talk about the daily stand-ups and the structure?
Yes, sure. So overall, we think of it, and I think that was the original plot. You guys are the core team, the 5 people, the 5 interns that work together. And you're when you're at Caltech or JPL, you had offices, a communal office where you would work every day. But you would actually meet with us, with me at least, every morning of every weekday. Then we usually have scattered meetings, either with Maggie or Hillary or with Scott throughout the week. And then each of the projects has what we call office hours with the project. So that's like 2 or 3 hours on one day during the week when you actually get to meet the stakeholders. And then on one day a week, we have a full 6-hour crit session or work session with all 4 mentors. So you definitely get to see plenty of the 4 mentors. We're available for questions, for individual meetings, for collaborative sketch sessions. Those are really fun. So you're definitely not on your own. I think there is a sense of you guys become a community, the 5 interns, and that's really great to see. And then you have the 4 different voices that are the mentors. And I think you can already tell just from this presentation that we all think a little different, we'll talk a little different, we're all coming from slightly different angles. So that gives you kind of the richness of experience. And then on that, we have the science stakeholders on the other side who have a problem that they're trying to solve. And they themselves usually have a little bit of not perfect understanding of how our program works. And that's always kind of fun also, because we have to tell them, okay, we're gonna get your data, we're gonna play with it, we're gonna try things, we're gonna show you some prototypes. At some point, we're not gonna show you things because you're gonna freak out if we show you, pipe holder with a styrofoam ball at the end. You might not understand what that's for, but we understand it and we love that. And then there's the whole iterative process between the mentors and the stakeholders just creates amazing solutions.
Yeah.
Hopefully that answers the question.
Yeah, thank you.
Yeah. Also, I want to answer Nancy's question, which is the CS lead more solo? So this kind of I'm laughing a little because we're actually a very small group, right? So we have 5 interns and there are 4 of us. And we originally kind of thought, oh, we'll have 2 designers, they all become a hub, and then each CS lead. And in the end, we all follow each other around like puppies, like, oh, are you going to go meet those end users? Can I come too? Right? So what we often find is that the CS leads and the entire team basically go to a number of like those immersive first few weeks where we're trying to learn about the data, the people, the processes, and the science. And we all tend to go, right? And it's less distinct about our mutual roles, because really what we're trying to do is ask interesting questions, understand the people and the data in the room, and ideate. It's really when we start to think about, when we start stepping up during our agile sessions, but what we're going to be responsible and accountable to one another for, that we start to say, well, our CS leads are really going to work on code and they're responsible for building the working prototype for one solution. But the collaboration is huge, both between the designers and the CS lead and also across the team. But yeah, but we do have distinct accountability or responsibilities for specific deliverables.
Yeah, I think to add to what Maggie was saying, there's definitely, I think, a sense of ownership of the code from the CS students. But I think if there's anything I've observed, that the CS students, especially as we're getting closer to the end of the delivery, are not at all just like, leave me alone and I'll go, just leave me to code. It's actually, the partnership becomes very tightly coupled at that point, because the design team will really understand along with the developer, but have a model of how the system should work through the prototypes that they'll have built. And there'll be lots of edge cases that the developers will need to think through, and they'll need the designer's input in things that weren't included in their prototype. Hey, what should I do in this case? I know you said make this yellow, but look, when I made it yellow, it looks a little weird against the gray. Like, what if I put a little bit more red in? So there's actually a lot of tight coupling between the designers and the developers. And I think, and in fact, it's a somewhat, it's an insincere separation when we do it in the best way. And I think that's one of the signatures of our program, because we really think that tends to help us ultimately drive towards a very interesting delivery, because by committing to a designerly approach, we'll have left on the cutting room floor 3 or 4 not quite as good ideas along the way, and often what we arrive at is something really innovative. And it's that approach, but to really committing to fast iteration, and that we learn to do together. And that I think it makes the developers better, more capable developers by understanding design in a different way. And I think it helps the designers to understand the complexities of implementation in ways that are really important to them. Does anybody have, it looks like, Adam, do you have another question, or is that it?
Yeah, I did have a follow-up.
Sure.
If nobody else, I know I already asked one, so I don't want to cut anyone else off. But so as much as there's the collaboration, are there any points where you say, yeah, an intern should take this and run with it, and they should be bringing now their own, like when do you expect maybe another way, when do you expect the intern to really take the lead and start to come up with their own path? Or does that ever happen? Is it really supposed to be always with the collaborative?
So if I understand the question, so I mean, there's two group of supervisors in this case. There's the stakeholders and there's the mentors, and for sure, the stakeholders, the JPL and Caltech researchers are going to have ideas on what they want. So from that point of view, you're definitely detached from their ideas. We're going to say, yes, that sounds great, but you're going to come up with your own direction from the beginning. We expect you to come up with your own direction. And the mentors are just going to help you guide. Now, as far as you being distinct from the designer, I think that we expect to never happen. Hopefully it never happens. Hopefully it never is just the CS person saying, okay, I have enough of the designers. I have an idea. I'm going to go on my own. I think there's a lot of understanding and going back and forth between the designers and the CS, that there's always something rich in the experience. But that being said, it is two designers being split across 3 projects. So there's, and there's a lot of work. So it's not like the CS person or a designer could do the whole thing on their own. It really requires the whole village to kind of work on these things. And yes, at some point, there was going to be a cutoff of the work saying, okay, now the CS person is going to figure out how to do this interaction, how to code it up, how to do this, and we'll circle back with the designer when we have a question about how to do this color map or do this particular representation. And I think there's a richness in the ability to work with real science stakeholders for accomplishing something really, really strong, and also the ability to actually work within a multidisciplinary team. I think is also something you get to take away from this program that's extremely valuable.
Yeah. So I kind of wanted to add a little bit to that while we use a lot of experimental methodologies or we experiment within the ideation, the end goal of the 10-week session is a kind of professional engagement with the labs and PIs. And the mentors are also available. That's kind of our job, right? Is to help facilitate that relationship and make sure that there's enough space for experimentation and discovery, as well as having concrete kind of expectations from our partners. So you're not expected to facilitate and manage the kind of issues and challenges that come up from a program. That's what we help do that. But we do expect the team to have a coherent and shared vision for the outcome. And to be able to communicate that and share it. And in the spirit of critique, beat it up a little bit and expand an idea on it. So I know we want to be sensitive to everybody's time. We're just a couple of minutes off the hour. Does anybody have any questions that you feel we could answer as a group, or would you feel free to reach out to us?
It looks like maybe Rebecca has a question. Why don't you ask that while we're still here?
Sure, thanks. This has been a really enlightening session. Super interested in the program. And I was curious, which maybe this would be a helpful wrap up question. In the context of the application process, you've already talked a bit about what makes a good portfolio in terms of showing process or transdisciplinary designers or engineers. If there were a few key traits that you kind of would prioritize or emphasize in a strong application, what do you think those would be in the context of maybe lots of people coming in with a similar breadth of skill sets? Like what makes a particularly engaging candidate stand out?
I would, if you go by the things that we ask in the form, you already kind of get a hint of what we value. We could have asked if you know Julia or if you know Adobe Spark, Apache Spark, sorry. But we're very, there's a question, React, D3. Those are all pluses. They're all big pluses. And usually, if you know those things, is because you've done a project that involves the need for those things. So I think the questions themselves kind of lead you to kind of what we're hoping for. But I think, like I said before, just any actual dealing with real data or even fake data, but with actual numbers and actually showing that you understand how to come up with interesting representations from that. I think every time we see that, it's like, okay, that person is definitely a must-have.
I'd add to that in terms of design. I think it's also clear that we have, as we say, some baselines around what kind of tool sets and experiences or specific tools from low to high fidelity. But I would say in terms of the characteristics of people who do really well, it's about curiosity and communication. Whether it's visual communication or facilitation, those are the two things, and kind of the curiosity for sure, because that's actually what motivated us to come together as a group, and also what motivates all of the people we work with is they are scientists, artists, and engineers. So asking great questions.
Thank you for that response.
Okay, so if we have any other questions, you can reach us online. We encourage you to apply or to share this with people who you think might be great candidates. And if this is not quite right for you right now, we want you to also be part of our larger community. We present finals, we have videos, we have our website at dataviz.caltech.edu. So take a look at some of our previous projects and drop us a line.
Yeah, it's nice to spend some time with everybody this afternoon. I hope this gave you a little bit of a insight into the kind of thing that we've been running and the kinds of things we've been able to do together. Feel free to reach out to any one of us to keep the conversation going. We're really looking forward to to continuing the program another year. And as soon as we know, we'll share the projects that we're going to select, and that often I think helps with students kind of to understand engage their own interest, and so look for that kind of heads up from us, and we look forward to kind of getting to know you guys better through the application process.
Thank you, everybody.
Take care.
Thank you.